well, so I can share that with you afterwards.
Awesome.
Let's see here.
So, I mean, just to review here, I mean, on our side, why the interest? So we do plan on building a skid steer this year, and we want to start on So one with RTK GPS. So we're going to use the SparkFun automation module so we can get precision motion on it, and also remote control. Now the other part that's a big deal for us is fuel. Like, fuel is a big cost in the operation. So actually, I would like to see if we can invest into the simplest possible device that can get us to meaningful fuel production. And maybe we can't do it this year as far as a finished product, but I'd like to see and start designing a system that would take common plastics and turn them into gasoline or diesel, and see what it takes to do that. So what is the minimum basic system that can actually be modular, expandable, but also this is not like some backyard experiment. This is like, let's talk about, okay, how do we actually get the abundant waste feedstocks of plastic into, convert that to fuels. So.
Okay. Okay, can I answer that?
No, Liberty, you're up. I have some ideas, but I want to hear what you're saying.
Yeah.
Okay. In terms of plastic, I would say the most trusted established technology is pyrolysis.
Mm-hmm.
Sorry, I'm in South Africa.
Mm-hmm.
Heat is in the year, so that's why my accent is a bit heavy.
Okay.
But despite that, South Africa is one of the most best pyrolysis vendors in the world. Not in Africa, but in the world.
Who is?
In South Africa.
South Africa is the best in the world in pyrolysis, yeah?
Yeah,
they have the best
companies that do produce quite a number.
The manufacturers there.
Stay away from China. I don't know if you know Beston.
No, I don't.
You know Beston. Okay. They are now all over Africa. They are pyrolyzing waste tires into powder oil. But now the problem with Beston, they just supply you the reactor. After they supply the reactor, they expect you to find the condenser, the gasoline from someone else, which makes everything complicated. Okay. And in the end, making everything to work with synergy is difficult because you're using different vendors. But there's a company that I know in South Africa.
Mm-hmm.
They provide you a full turnkey solution, from the reactor to the gasoline system. Because basically, let me put it this way: when you pyrolyze tires, right?
Mm-hmm.
Yeah, that's the word. Just type Beston on LinkedIn, that word on Google, it will appear.
Okay.
So with waste tires, let me just look for the project diagram. You first pyrolyze them into oil, so it's just a black liquid, and thereafter you then basically you put the oil in a high pressure system reactor, bubble through some hydrogen, mainly because you're trying to remove some hydrogen sulfide and the oxygen compounds. Because when you pyrolyze the plastics, there's going to be a lot of oxygen compounds that don't contribute to your fuel. So when you introduce hydrogen, it then substitutes in place of hydrogen, then you get a crude kind of mixture that you get. And thereafter, you then fractionate it into diesel, gasoline, and light like LPG gas in essence. And then the quality of fuel that you get there is just top notch.
Oh yeah, and this is the tire route specifically?
That's the tire route and also the waste plastic route.
Okay, so if we were to what is the smallest turnkey system that they produce? So it's not Beston, but another company. What's the other company?
The town is called Technotherm. So they have a full lab in Johannesburg. I don't know if you know anything about South Africa.
I've been I worked for Eskom for one summer in 1995.
Wow.
Yeah, and then I kind of left because we were working in renewable energies and like we weren't doing anything. So I just like left and traveled and all that.
Yeah,
no, it was interesting. It was good.
Eskom is the naughty child. They always take money from us and don't give us the required power. But anyway, that's another story for another day.
Yeah.
So, Technotherm is based in Johannesburg. I think were you based in Secunda or were you based in Johannesburg?
Okay.
Where were you, Marcin, when you worked with them?
So that was in Johannesburg.
in
Okay.
Johannesburg. Company is in Johannesburg. I don't know if you know Vereeniging. There's a place called Vereeniging.
No, not really.
No, okay, it's an Afrikaans word. So my apologies for that. So they are based in Johannesburg. So they have a full lab. They will test your plastics. They will verify the amount of bio oil that you will produce, and then they will tell you how much gasoline. Sorry, in South Africa we say petrol. Then they will tell you how much gasoline that you get out of it.
Mm-hmm.
Yeah.
So do they offer? Can they actually offer a turnkey system for us?
The whole system because they actually have a system that is larger than a pilot scale that is pyrolyzing waste tires into powder oil, and then they are sending that powder oil to Shell.
Okay.
So they will provide you the whole full system if you want.
Yeah. So I mean, that sounds like big scale. So
Yeah.
is that anything like that possible on a scale where you're talking about, say, like 50 gallons an hour or something like that kind of a system? Like say, yeah, like we're talking
I'll
about
try.
50 gallons an hour to like 50 gallons a day, like just enough that start with small batch system. Like what's the minimum viable thing that we can actually do it in any effective way? So I would imagine something
Let me.
like a ton of plastic, you throw it in a hopper and it goes from there, or whatever, however it goes. Like imagine we take a ton bale of plastic.
The good thing is that he is a small system that can take about 15 kgs per hour, or 15 kgs the whole system. So it does have small systems, even on biomass, and also large scale systems. So I think for your system, you are looking basically at a pilot scale. That's what you're looking for. So for me to give you a good answer, give me at least today and tomorrow. I'll talk to the guy, the owner. I know him. Then he will
Oh,
give me the figures that you require. Then I'll get back to it.
that's a Technocam.
Is it
Technocam. Technocam.
technotherm or technochem? I put the link in
Yeah.
there. I don't know if that's what it
Let,
is.
let me let me type it for you in the chat. Technocam. The
I
owner is
put
called
something in the
Richard
chat, but
Birmingham.
that might be a different one.
That's Technet in South Africa. That's the one. That's the
Is that
company.
the link that I put in there? Is that the right link?
Yep, that's him. Yeah,
Okay,
that's the right link.
okay, great.
How did you guys get to know each other? How did you guys meet?
I
So
started.
there's a comp. Oh, sorry.
Oh yeah, no,
Yeah, yeah.
I mean, me, you and me. I started PAGWM about 2.5 years ago now, and I had the website, and I had the LinkedIn, and Liberty just found me. He was looking around, and he hit me up, and we started chatting, and we're for whatever reason, we're like kindred spirits across the world here.
Oh,
We just click really well, and we have a lot of the same philosophy with regard to, waste energy type processing, and just generally trying to figure out new ways to deal with waste management, right? So,
so Keith, are you
uh,
actually is PAGWM, is that actually your full time thing? Like that's your main effort?
no, no, no. It's not yet, not yet. We're trying to get there, but
Okay.
it's definitely something that we're trying to get going. Obviously, we found that trying to do new technologies and consulting and all that kind of stuff is a little bit more difficult than you first imagined. But
Yeah, yeah.
we know that this is going to we know we're making a bet for the future. We know there's eventually,
Oh yeah.
the dealing with waste as far as like just landfilling or
Oh yeah.
burning and that sort of thing is not sustainable. So we're in this to kind of for the future, for the long term.
Yeah. Keith, if I may ask, what is your main endeavor right now? What do you do most of the time? Besides
I'm a
suffering
software
in the
developer.
factory farm for the last 2 weeks in December?
Yeah, exactly. No, I'm a software developer,
Okay.
and so and then I'm just an econ nerd on the side, and then I like this has been a passion of mine for about 10 plus years now, as far
Yeah.
as like waste energy systems. So
Yeah.
And
we're
Yeah. Yeah. We did
go ahead,
do
Liberty.
biodiesel for some time. Like early on when I arrived at Factory Farm, we actually had a veggie Suburban. We ran it on vegetable oil. We also made some biodiesel. We also did run an engine on on charcoal. So we have done a few experiments, just basic experiments that got our hands dirty in some of these things. Yeah.
Yeah,
And
just like
and I'm a
an old style gasifier. Go ahead, Liberty.
and I'm a chemical engineer by profession. So I've been in the chemical industry for about 15 years.
Yeah.
But in terms of waste to energy, about 8 years. So I've done a number of commercial projects in South Africa, Spain, Germany. I'm now coming to America. So I can design a full-scale biogas system, pyrolysis, gasification, I would say up to a pilot scale.
Yeah.
Okay, that's great. And so you've designed you've commissioned these designs for companies. So you got your systems integrator, effectively.
Yeah. Another thing is it's a teamwork thing. So I do the designing, the economics, and then we have a couple of guys that are professional engineers that go on the ground that do the whole commissioning and stuff. But to commission a waste energy system is quite easy, to be honest.
Yeah, yeah. What is
Yeah.
the main? So when you install a system, if you have the design, what is the main cost in the system? Is that just metal and fabrication, or is there a lot of specialized components?
So now, based on the economics, it's your sorting system.
Your
For
sorting
example,
system.
since you want to use plastics, basically you're dealing with MSW, right? Municipality waste. So you need that plastic separated efficiently, of which I'm glad Keith is here. He has experience in terms of sorting. He has done, I think, how many companies have you visited, Keith, in terms of sorting?
Oh, no, as far as like all the research that I've done with regard to this stuff, I've visited every recycling plant,
Yeah.
within Central Texas and all that kind of stuff. And so I've done the research with regard to,
Wow.
what this kind of takes and all that kind of stuff. So it's not, it's not a zero cost type endeavor to make sure that. And that's one of the reasons why people feel like recycling is a bit of a scam, is because you can't just throw any plastics into these systems, right? You have to be very picky about these plastics. Liberty knows exactly which
Yeah.
types of plastics you're able to use in this pyrolysis type system, and unfortunately that leaves out a lot of the common ones, which is kind of rough, which is why we were thinking of alternatives with regard to, just a general, plasma assisted gasification, which kind of takes care of all of that issue, with, other problems associated with that as well, as far as energy consumption. But,
So
I think,
Well, now, the good
Go
thing
ahead.
about pyrrolysis, unlike plasma, right? Plasma is very energy. It consumes a lot of energy. That I
Yeah.
can promise you. But now with pyrolysis, when you pyrolyze plastics, right, you're gonna get biochar. I don't. It's called pyrochar. I think that's the right term, which you can use as energy source. Then you get your bio oil, which you then convert to gasoline, right? Then there's a gas fraction called syngas. You can then route that syngas back to the reactor. So in the end, after about, let's say, 1 day or two, your system will be energy self-sufficient. You'll be using your own syngas to run your own system. That's how wonderful pyrolysis is.
So the plasma is used to start the process, or no? This is
No,
Plasma is
that
a
would be a
different
separate system.
technology altogether.
Different technology, different system for different use cases, right? And so if you can find a decent source of non-chlorinated type plastics, right?
Plastics, yeah.
And that actually might be very feasible in your area, just because you don't have a kind of a large recycling facility that you'd be competing against as far as collections, right? So you could, in effect, gather up these different types of plastics. I forget exactly which which ones we're able to deal with.
my immediate
But
my
Go
immediate
ahead.
thought is Maysville, 1,000 people even. So you talk about your automated RTK GPS mobile vehicles, and then pickup. So now we're 3D printing the containers and actually picking up the containers, and people actually separating plastic for us and other things. I could see that happen. That's doable. It's built so much on our stack. So we talking about open source machines, RTK GPS navigation, 3D printing, and all that. So, oh man, it's exciting because it's solving a problem. The waste that right now is a huge issue for anybody. You just hire the
you could
dumpsters.
you could do that. You could do that in your area. I feel like in Austin it would be a harder sell because we'd be competing against two very large recycling facilities who really want those plastics. That's really the only thing that they're interested in with regard to plastics. The rest of the stuff just goes straight to landfill. They sort through it and they just throw it out. There's some recycling centers who do some interesting things with it. They shred it and they'll turn it into some kind of mold items and stuff like that. But that's a little bit rare. So that's
Keith, with the type of stuff you're working on. So you're talking about actually separating the full waste stream, not just like, oh, here's a plastic bale and you're separating it. You're talking about just from the raw trash stream. When you said recycling centers.
No, that they have it's strange the way it works in this municipality down here is that commercial commercial enterprises need to recycle. They need to have a recycle bin, and so they can toss any kind of recycled material into that bin. Households do it through the city. They have a recycle bin and they throw all the recycled material in there, but all the recycled material is mixed, right? So you got your cardboard, your paper, your plastics, and all that kind of stuff, and nobody is really doing it correctly, right? So you're throwing in plastics and cardboards and all this kind of stuff that just won't work, right? And so recycling facilities will sort through that and they'll just go and toss a lot of that stuff out of there. But also it's incredibly dangerous work, right? You'll get batteries, you'll get flammable items in there and all that kind of stuff. Recycling centers deal with terrible fires every other week or something along those lines. So it's a really kind of rough, dangerous kind of operation, which is very funny if you think about it. Yeah.
Wow.
But yeah, so but I feel like if you were very specific as far as the types of plastics that you would accept, that could absolutely help out, in this instance.
And just to stress one more point, there's always something that we always mention when it comes to waste. But in terms of technology, there's a saying, there's no free lunch in engineering or in science.
That's right.
So if you benefit in one area with your technology or system, you have to pay in another area. So now, as I'm saying, I'm recommending pyrolysis mainly because based on my experience. So if you choose plasma, you have to deal with a lot of high energy cost. And also the maintenance costs are extremely high. But it's better in terms of treating any form of plastics. That's the main advantage. With pyrolysis, it cannot treat every form of plastics. That's the main drawback. But it can be energy self-sufficient, and it gives you a good yield of your pyro oil. With incineration, you're just converting all the plastics to energy and to electricity. And there's other form of waste management systems that are coming on board. But no matter what they tell you, just take it from me. There is no system that is perfect. If it gives you a good area where you benefit, there is an area where you're going to pay the tolls.
Right.
That's the philosophy.
Right. Yeah. It's like what is one of the interesting things that we ran across with that farmer who had a gasifier, and he was gasifying his wood waste, right? And unfortunately, what happened was his entire land was covered in tar. Eventually, like everything ended up being covered in tar, right? Just gasifying wood produces tar. That's one of the side effects, and it's in the air, and it just covers everything, right? So whatever technology you go with, you have to understand, what your benefits are going to be and what your costs are going to be, because anything that seems too good to be true is very definitely too good to be true. And that's what we found in all of our investigations. Marcin, I know that you're interested in creating something that is that you can put out there as an open source project, right? That is reproducible, that other people can copy and that sort of thing. And I'm assuming these waste management systems are part of that, correct? Right.
Yeah,
So
yeah,
if
of
you're going to
course.
do pyrolysis, you want something that can be put out there as far as design and all that kind of stuff that other people can take and copy and replicate. And so,
But of course, with the caveat that you're actually working out all the problems. It's not like you put up some crappy stuff that pollutes or doesn't have good yields or whatever. We're talking about refining that and getting in all the proper to the point that it's actually certifiable and replicable on a larger scale. This is not about our backyard. It's about a system that can be viable and can pass EPA or whatever, this and that.
Yeah. And so whatever.
Yeah.
Go ahead, Liberty.
So the company does, because they have a presence in America, in Virginia. So they've installed
Okay.
they have a partner company in America that they work with. So they can liaise with them. And then what you call it? I'm losing my train of thought now. So they have fully trained engineers. They have a fully equipped laboratory with state-of-the-art equipment and fully trained chemists to test every product that comes. So everything is basically certified. So when they tell you that they will fabricate a machine for you, definitely it's certified and it will work accordingly.
Mm-hmm.
That I can promise you.
Yeah.
They are not experimenting. They are people who know what they are doing outside.
Right. No, with the caveat that that's not something that kind of technology is not something that you can share, right? I mean, you're buying something and that is patented and that is closed source, right?
Yeah.
And so that's the trade-off in this case, right? If you're going to go with some established systems, and I think you can eventually get to a place where you create a system where you have all the proper filters in place, and you're not leaching dangerous chemicals into the atmosphere, that sort of thing. But that's definitely an iterative process if you're going to do something bench scale, start from scratch, right, sort of thing. And so that's where you're at. That kind of thing excites me, absolutely. Having an open source design for a gasifier pyrolysis unit for plastics and all of that kind of thing. That'd be absolutely wonderful. It could start thousands of small little companies offering these services instead of giant megaliths, right?
Yep.
But there's that's not an overnight process, I don't think, right?
Yeah.
So there's it's kind of what you want to do, where you want to go, what are your goals, sort of deal. Right.
Yeah, well, we want to open source it from the. No, I mean we want to open source it from the ground up. If it's proprietary,
right? There's no company.
Yeah, that's all right. So that's why we might have to do it from scratch and stuff like that. But I mean, of course, you build on industry standards, whatever information is open and all that. The general procedure is after you got your requirements, you examine what the industry standards are, which of that is already open technology versus not, and you go and iterate from that. So you're not starting from scratch by any means. You just don't have access to the stuff that has been made in the last 19 years.
Yeah.
That's all.
Yeah, that's true.
Yeah,
but the industry has been around 19 years ago in 2007, right? So whatever technology at that time was available, we know we can probably access that pretty fully, right? I mean, you look at the patent cycle. I mean, there's proprietary stuff.
But the thing is, like for example, when I design, because I have about 3 commercial scale biogas systems in Germany, Spain, that I designed on my own as a lead engineer, certified by my manager and all that, and they are fully operational.
Yeah.
And then when I met Keith, we decided to make our own small-scale biogas digester. But then I knew there's going to be some IP rights and copyright issue. So instead of using a similar design, we used an IBC tank. You see that tank flow that you put water in? The IBC tank?
That's what Marcin
That's the-
wants to build one of those. Yeah.
Yeah, exactly. But you need one that you must use the one that is black.
Mhm.
So I've built one here in South Africa. We built one in Texas. That thing works perfectly. Even the quality of the
So
biogas.
what device is this?
Okay, let me try
Biogas
to-
digester, right?
Yeah,
Mhm.
let me try to share my screen just to show you what I'm referring to.
Yeah.
It's a biogas digester.
Mm-hmm.
Yeah, Liberty
Oh.
has a working one over there. The one that I built got destroyed in the storm back in May here. A tree fell right onto it and destroyed it. Yeah. I have
After
a
we were
picture of
done building it for several months.
Yeah, exactly. It took so long because I was doing it half time. I feel like I could build that thing in a couple of days now.
Yeah.
That is true. Let me just switch accounts. So in
So
terms
you
of
guys
the
were
product-
producing. So you guys were actually getting usable gas.
No,
very
I didn't
much.
get to that
Also,
point. But he did.
Okay.
Liberty has it.
Okay, just give
Are
me
you
a
familiar
second.
with those systems as well? Things like gas purification and compression of that kind of gas, because that's like an immediate fuel for cars too, for natural gas
Yeah, so
cars.
it's either you remove the CO2, which you need maybe a membrane system or a PASA system, or you can just produce high quality biogas system without any H2S. And there is cars that run on biogas with H2, which is CO2 inside. Okay, let me just put it up. Okay, I'm putting it up now. So there's the video. Okay, there we go. So the one that me and Kit built is quite similar to that. The only difference is that this one is only two tanks.
Are you sharing? I don't see the
Oh,
screen yet.
sorry. Do you see the screen yet?
Let's
Do you
see.
see it now?
Not yet. It's probably popping up here. Here it is.
Okay. All right. Marcin, can you see it?
Yeah.
Okay. All right. So this is the biogas storage tank.
Mm-hmm.
Basically, it's a bladder or a
Yeah.
balloon, but it's made of tough plastics. And these are the IBC tank. These are the digesters. And these are the pressure monitors.
Mm-hmm.
That's the scrub. Okay. So on this day, we're feeding stale bread. So basically, this is the input.
Mm-hmm.
So the biogas, the waste goes all the way down because this pipe goes all the way down.
Mm-hmm.
Then the waste then gradually rises through the tank. Then as it rises, then the bacteria then converts that waste into biogas.
Mm-hmm.
And then so that's the stale bread.
Mm-hmm. Mm-hmm.
Okay. So the reason why it's black because you're trying to utilize the sun.
Yeah.
Because if you want to use electricity in Africa, electricity is not that abundant. So we designed a system that uses something that is natural. But you have the option to put in a heating system around your digester. It's another option. So what you see there is high quality organic fertilizer,
Yep.
which this lady was using. That's a greenhouse.
Yeah.
She was using it and she was getting good quality seedlings out of it.
Yeah.
And then that's the fertilizer. Okay,
Mhm.
the pipe is okay. Sorry, this white pipe is it? This white pipe is basically your scrubber. There should be two of them anyway. So halfway is iron filings to
Mm-hmm.
remove the hydrogen sulfide,
Mm-hmm.
and at the top here is zeolite, so it remove the moisture. So if you
Okay.
want your gas to give you like a high heat value, it needs to be as dry as possible. That's the
Mhm.
purpose for it.
Nice.
Yeah.
How much is zeolite per
And then,
kilo? Like, is that's readily available?
it's quite cheap, very cheap.
It's
to
pretty
order. In
cheap.
South Africa,
Yeah.
it's about 70 rand a tin, which is about in US dollars, that's about approximately, I would say about $6, $6 or $4 a big tin.
Like a couple of kilograms or something, or
I
I
was
would
looking.
say at least about 15 kgs. Oh
15
crap!
kgs. Oh, that's okay.
Yeah.
That's like 50 cents or less a pound, a kilo.
So that's your biogas, full
Mm-hmm.
of biogas. Now I'll show you the test that we did. So when we tested the flame, you'll see the beautiful flame that we got. So this is something that is very practical and feasible.
Is it
That's
supposed
the
to be
flame
white,
that
or
we
is it
got.
supposed to be? Is the white good?
It's supposed to be totally blue. So on this particular day, it's just that the zeolite, this what you call it, the iron filings were used up. So when we saw the what you call it, the white flame, we then check the iron filings. So it's a sign that there's a bit of H2S coming through.
Uh huh.
But then if you fill in some iron filings, the flame will be totally blue.
Yeah. Did it
Yeah,
smell?
not at all. It was just clean. Even the fertilizer, it was just
No, but
clean.
the gas coming out with H2S, that's you can smell it, right? So it's a safety valve, safety check.
Oh yeah, no, it's a safety check. But the thing is, this yellow color, it's a doesn't mean that the H2S is a lot. It's just that there's a few amount that is escaping, mainly because the iron filings were used up.
Wow.
But if you put in a fresh batch, like a fresh batch, I promise you, this flame will be totally blue.
Yeah. Nice.
Yeah.
How long
So
did
this is the lady that,
How long did the filings last?
unfortunately, depends on the environment. So where we installed this system was on the northern side of South Africa, and it's very humid. So it's more like what do you call it in America? It's Houston. Is it Houston? Tim?
Oh, yeah. Well, like Florida, like a South Florida or something like
Yeah.
that,
So
right?
it's very humid. So when it's humid, the moisture easily builds up around the scrubber, and that moisture then penetrates the iron filings.
Do you
But then,
regenerate the filings, the pyrite back into filings?
no, unfortunately, when you combine with H2S, I mean, the iron filings are very cheap. That's why we chose them. There's better systems that are more expensive that you can buy, but they're extremely expensive. But iron filings are very cheap. So they react with H2S into iron sulfide, something. But you can just throw that in the ground and put in some fresh batch of iron filings because it's quite cheap. That's a
Mm-hmm.
good thing. Yeah.
Is there any use
But
for
the
the pyrite?
zeolite, it's a good fertilizer because it's a sulfide. It's a sulfide side, so it's a good fertilizer.
Really, pyrite is a good
Yeah,
fertilizer.
yeah,
So you can spread it into the farm, part of the farm ecology.
yeah.
Oh wow! Oh, I didn't know that. Do they use pyrite as fertilizer, like in the commercial world, instead of sulfur
Okay.
and iron?
What do you call it? Remember, there is different forms
Probably
of
not in the
fertilizer.
commercial world. They're not
Yeah,
going to make money
like
off of that.
no, the thing is, you get different type of fertilizer. You get ammonium nitrate. That's the most common one. Then you get ammonium phosphate. That's another one. And then the quality of sulfur that you get is going to be iron sulfide, but it's not sulfide like pyrite. It's a form of iron sulfide. It's a bit difficult to explain because
Fe2S.
more or less along those lines. But what we have seen that you can use that as a fertilizer because it's a source of sulfur.
Yeah.
Yeah.
Mm-hmm. Okay. Very
That's
nice.
cool, man. Yeah,
Okay.
I like it.
But the zeolite can be regenerated. So if it's used up, you can just take the batch out, heat it in oven for about 3 4 hours, then use it again.
Yeah.
But the filings, unfortunately, you can't use them again.
Okay. Yeah.
Well,
So this
here's so
system we can
good.
we can share with you, me and Keith, because there is no IP issue with it. But pyrolysis, there's a number of areas that you need to look around.
Yeah. Yeah. Yeah.
So here's the idea that I had is that you're probably going to want to incorporate multiple technologies to generate fuel sources, from various areas, right? So you'll want to, have your biodiesel type of, system, based off of like used oils and that sort of thing. You'll want to have a biodigester system that you can get product from, and you'll want to likely have a pyrolysis unit, that you can use to, deal with plastic. So if you have like maybe those three systems combined, you should be able to produce a decent amount of fuel with relatively low energy costs, and and deal with a lot of the waste that you might otherwise have to mess with.
You wouldn't do wood to pellets to charcoal in that. It seems like low-hanging fruit. We can do, if we got the sawmill up and running, we can get pellets and then make charcoal.
Yeah,
pellets.
yeah. You're talking about creating just a gasifier off of wood pellets. That's a common thing. And there's issues that you need to deal with there. Liberty's well versed in that sort of thing.
Liberty
So
versed in
basically,
charcoal as well. Charcoal from wood.
yeah. So what you're looking at basically it's slow pyrolysis. That's what you're looking at. But the only problem is that when you pyrolyze your biochar, your biomass into biochar, you produce quite a bit of syngas, and that syngas needs to be taken care of. So it's either you flare it or you then run the system with it. Those are the two things that. But then there's a guy actually who's doing that here in Cape Town. He's pyrolyzing pine wood into biochar, which is then selling to Germany and Europe, because it's a soil enhancement.
Yep.
The thing about it. So he then when he's done pyrolyzing the wood, he then mixes that with some bit of fertilizer. Then it then combines with the soil quite nicely. The only problem is that it's producing a lot of vinegar, wood vinegar. So that
Sorry,
wood
the
vinegar
problem is what?
must go somewhere.
It
Wood
produces wood vinegar.
It's a lot that you're gonna produce. So that wood vinegar must go somewhere, and it smells like crazy. Oh man, it even sticks to your body. That's the problem. As I told you last time, there's no free lunch. So
That's
it's
right.
easy to convert biomass to biochar, but the main byproduct that you deal with is wood vinegar, and it stinks.
And the tars, right?
Tars. And the tars, oh, they come together with the vinegar. So those two need to be taken care of.
What's the standard?
Unfortunately.
How do you get rid of the vinegar and part? Like, what do you design into the system so you got?
The current guy that is in Cape Town, he's selling it as what do you call it, as a wood preservative. It's an idea that he's exploring, I would say, but it's not practically feasible.
Okay. Or how about,
Yeah.
so is this close to, is wood vinegar close to acetic acid? No, that's a different thing.
It is close to that, but it's different because the tars introduce a lot of hydrocarbons in your vinegar, so they become totally different from acetic acid.
Yeah, pyrolysis.
Yeah, so it smells tar there's a tar smell, I promise you, and it's not a nice smell. It will annoy your nostrils big time. I promise you. Actually, it's a good drain cleaner. If you put it in the drain, no matter what was there, all of it will just dry. It's a good drain cleaner.
Drain?
Yeah.
Instead of Drano?
Yeah. The drain pipe.
Yeah.
Right.
Instead of
Instead
Drano.
of, say, potassium
if you're-
hydroxide.
Yeah. So if your drains stink, that product, if you just pour in about, let's say, 500 milliliters and just leave it there for about 2 hours, whatever was there, whatever bacteria was there, it will just kill off everything. The only
Okay.
problem is that the tar smell will stay a long time in your house. Oh, that's the bad part. It's gonna smell for a while because of the
Tar.
tar smell.
I mean, tar does not, tar like creosote smell?
Creosote, yeah, similar to creosote. It smells like crazy for a couple of days.
Mm-hmm.
Yeah. Probably makes everything a little bit unlivable, honestly.
Oh man, as I said, there's no free lunch. Unfortunately, you have to pay somewhere.
So what do you do
Yeah.
with it? What do you do? Can we turn it to to EVA? Glazing?
I know. I know. It's an acid. So currently there's a few studies. People are exploring different avenues to convert it to feasible products, but because of the tar, it makes everything complicated, unfortunately.
Yeah. So, but I mean, that's obviously like another, possible avenue, as long as you're able to figure out what to do with the products, the side products that come out of that, right? Because
So what do
because
people
that's a big
typ-
issue.
what do people typically do with it if they're making charcoal?
What do they just
Sorry, come again?
toss it, Liberty? What do they do with that stuff? They just toss it in the dump or something like that.
Which one? Sorry,
The
the
with the vinegar, with the
or the
vinegar, the
vinegar.
tarish vinegar.
So
Yeah.
the guy in Cape Town, because Cape Town is like California, we have some crazy environmental rules. They don't even play the guys. They find you dumping something, they will fine you like crazy.
Yeah.
So what he's currently doing is just storing it in storage tanks, and he's trying to find ways to use it. And
Like
one
a huge
area that
storage tanks of vinegar, right? Yeah.
big time. So is because he stays in a farming area, he's experimenting as a pest control. So there's a couple of farmers that have agreed to run some small pilot scale where they use it as a pest control, what you call it, pest control, like a
Yeah,
pesticide,
product. Yeah,
I would
pesticide.
say. But as to whether it will work or not, they are not sure, but they are running experiments on it.
Yeah, it'll keep people away. That's good.
That is true.
Okay, but if you do, how much can an acre hold for like actual real fertilizer use? Like, um, how much of it can you spread per acre, for example? Can some of that be used for agriculture?
Well, we don't even know if it's going to be an effective pesticide either, right? So that's the experiment that's being run. It's a theory
No,
at this point, right?
it is a good pesticide. It's been proven
Yeah.
that it is a good pesticide. But the
Okay,
problem is how much to put. That's where the
I
question
see.
is. Because
I
you don't
see.
want to put too much,
The dose.
then it kills your crops. But then you don't want to put too little where it doesn't do the required job. So it's
Yeah.
about how much should we use. That's
Right.
the big question. Yeah, that's the
Right.
big
Right.
question.
Right. Got it. Got it. Got it. That's interesting. Yeah.
Yeah.
But to get to the main, so you have possibly these four like energy production systems that'll help you deal with the waste that's coming off of your property and the general community, and you'd like to turn these into open source projects that people can iterate upon, and you would definitely need that because
Oh,
you need
Yeah,
people with
absolutely. I mean, no free lunch here. I mean, so
electrical
yeah, I mean, first,
engineering and in expertise and all that kind of stuff as
yeah,
well.
and then distillation, just like other distillation, that's part of the process that's in pyrolysis of plastics. So it looks like more chemical plant, but that's the thing. Now
Yeah.
getting into open source chemical plant territory, which doesn't exist. I don't see it. There's some backyard experiments, but nothing. I haven't seen anything serious in
Yeah.
that realm, especially open source. But if you talk about now, well, my question is, okay, well, what's it take? What is the basic thing here? You got metal vessels, piping between them, valves. This basically your own fractionating columns that you're now starting to open source. That's where it gets
Yeah.
interesting. And now you can talk about modular systems that can do this.
So Liberty, is it something that that we could try and like kickstart to get some designs for these various systems,
Let's do it.
to
Open source distilling
put out
column.
there.
I mean, open source distillation was definitely a part of that, right? So I would see that for plastic or anything, whether it's wood vinegar or anything, controllable
in
systems
terms
for
of
that.
pyrolysis, I'm not quite sure. I need to find out. But with biogas, our system is quite open source. That is possible. Yeah.
Biogas from the
With
you're talking about from the digesters.
The digester.
yeah, from the digester. Yeah.
Mm-hmm. Yeah.
And then how about the the biodiesel type of
Oh,
system where you're dealing
we,
with like used
we,
oils.
we do have one. Remember the one that I designed, Keith? We do have one that
Yes.
we can share with you. We do have
Yeah.
one.
Right. So that's another one. And then wood-based gasifier. I think uh, that should be. I mean, the plans for that have been around since easily
Yeah.
accessible since the 50s, right? So that should be something that could be designed in different ways.
So
There's lots of
I,
different plans for it.
I forgot he gave me a sample, so it was here somewhere. So that's the wood vinegar.
Oh, look at that.
So
Ah,
the brown color is basically your wood vinegar with oh crap, I hope that appears with some tar suspended in it. And if you open it up, it smells like tar like crazy.
so the bottom is a lot of the tar. The middle section is the vinegar part.
Actually,
Okay, it's
it's
all
just
mixed
mixed
together, right?
together. I don't know how it's coming through, but it's just mixed together. It's just a dark brown solution.
Yeah.
Uh-huh.
Yeah.
Yeah.
Now, if
Um,
you distill it, what's pure vinegar used for? Is that useful?
I know the problem is that remember whenever you have tars, that means there's hydrocarbons in it. So if you distill it, you won't get pure vinegar. You'll get vinegar with a number of hydrocarbons in it. Unfortunately.
Well, yeah, but then you carry on the distillation process further, right?
The problem is how many times do you need to distill? Because remember it's about the economics. So if you wanna
Yeah.
distill it 10 times, only let's say you have about 1,000 crap. Uh, you don't mind if I speak metrics, right? Sorry
liters,
about
yeah,
that.
go for it. Yeah, yeah.
Okay.
Yeah.
Marcin
Let's
is
say
he's a metrics guy, you know.
oh cool. I'm glad.
Hmm.
So now let's say you have about 1,000 liters, right? Which is about an IBC tank.
Yeah.
Let's say that's wood vinegar. I'm talking about from economic point of view. Let's say you distill about 10 times, 10 times. And each time you're removing all that waste. And when you distill the product, right, you are using a lot of energy, remember? Energy needs to come from somewhere. Maybe you're using natural gas or electricity, and that costs money. And then if you after you distill your vinegar, and let's say you get about 98% pure vinegar, and then let's say from 1,000 liters, you get about only 500 milliliters or less than a liter. It doesn't make sense from an
Right.
economics point of view.
Right. Yeah. You need to make sure the juice is worth the squeeze for whatever it is you're doing
That's the
there.
thing. Because vinegar
Yeah,
is quite cheap. That's the problem. It's very cheap.
that's right. Yeah.
So for you
Yeah.
to break even, that means your vinegar needs to cost about 20 times the normal vinegar, which obviously
When you
is
say normal vinegar, are you talking about food grade vinegar, or this is not? I mean, in principle,
uh,
you could get it to like food grade vinegars.
I'm not sure because of the price of tires. I'm not sure, to be honest.
Yeah. You just would never get to a food grade vinegar.
No,
It'd be like an industrial type vinegar or something
industrial,
along those lines. Right.
which is far much cheaper. That's the worst part. It's very
Yeah.
cheap. Industrial.
Yeah. It's easy to get that, right?
Yeah.
Um, yeah, that's really cool stuff. Um, so as far as the like a next step type deal, Marcin,
Yeah.
what would you like to see? Who else do you have in mind as far as kind of like going into a project like this? Do you have any ideas as far as
This is
other
something.
people that would be willing to contribute?
Yeah, I know it's don't have any specific names outside of Jack, who expressed some interest on the pyrolysis thing. But for us, as far as getting a system going as a pilot that then can be made into a real thing, we're actually producing fuel.
Yeah.
So take the pyrolysis plastic route. The idea, the way I look at it is, okay, here's some requirements and specifications. We just start developing it, and then see how far we get based on. Let's look at the economic analysis here, and what are the economics? How much can we save in how much time? What's the capital expenditures, and how much can we actually produce? And if the system makes sense at the scale of, say, like 1,000, like for us, for our own operation, it would be like, well, how much do you need for when you have multiple machines running all the time and construction and all that and agriculture. So on a consumption scale of replacing all our vehicle fleet and tractor fleet, all that, all the mechanical fleet. So I mean that's going to easily get into like, I mean what do we do right now? We got like 40
Well, I
gallons
think the
of fill
first,
up of the truck, right?
yeah.
And that's like do that every couple of weeks if we're in action, and that's just
So,
one car. So you're talking about thousands of gallons immediately that are the immediate need, thousands of gallons per year. So can we design a system that produces what's the minimum viable system that we can do? So we like to look at it as here's the modular system that we can devise and then scale it as needed. But I would look at it
so,
simply here's the economic returns. This can't be tinkering. This is about industrial production on a small scale. So eventually getting to that where it can be highly replicable for anybody. So I'd like to invest in it, knowing that there is a waste stream issue. I would want to invest into it as much as possible, and then get the interest rolling in this with a bigger vision. It's like here's the big numbers. Here's how much plastic waste and other waste or whatever route. I mean, let's confine it to. We started this discussion on pyrolysis of plastics. Here's the numbers for plastics. Here's how much we have
Okay.
access to. What's it cost to, how many can we set up a viable operation right in Maysville just from the waste in town? The
That's
amount of
probably a
trash we
good place to
generated in
start.
the last workshop, yeah, we can do that. There's tons of plastic
That's
trash.
probably a good place to start, right? So
Yeah,
how much viable plastic trash, not just plastic trash, how much viable plastic trash is required, and then how much is available, right? How much are you going to be able to harvest on a regular basis? It's a problem that a lot of you know uh, recycling entrepreneurs run into, where it's like I have a great idea for recycling materials. There's
yeah.
just I can't find the source. I have no
yeah, of
source of
course.
materials, or it's difficult to find, or it runs out, or it's sporadic, it's seasonal, that sort of thing, right?
Yeah, yeah,
So that's probably a great place to start. Liberty, would we be able to determine, you know, what how much material we would need in order to be able to produce via pyrolysis a certain
Yeah.
number
So,
of gallons or liters per year?
so if you can give me the amount of petrol that's required, maybe for, okay, the thing about waste to energy or waste to biofuel, it's a technological project. I would say don't start large scale, start modular. That's my
Yeah,
advice for you.
right.
Because I've seen guys like in South Africa and America where they build a large waste to energy system. It's published in the media. It's gonna be, you know, innovation. It's gonna, change the world. Only for the system to have all kind of technical issues. Money is being thrown in and then it's abandoned.
yeah,
So I would say if you can give me the amount of gallons that you need maybe for
yeah.
two
I
vehicles,
want
two or three
5,000
vehicles,
gallons, 5,000 gallons a year.
yeah,
Okay.
yeah,
Yeah, so 50
okay,
gallons
that's
a
a good
week.
starting point.
Okay.
Sorry,
50 gallons a week.
okay, that's 5,000 gallons a year. Okay, yeah,
50 gallons a week. Okay.
Yeah,
All right.
yeah,
That's a
50
good
gallons.
starting point.
So
Let's
basically, we're gonna work backwards. That's what we're gonna do.
right.
yeah.
Let's look at
Let's
the
look at what it
viability
takes
of
to do
that.
that. Now, what about the idea of so if we can score garbage bales at $50 a ton, is that doable? Yeah, that would be doable, wouldn't it be?
That one obviously the economics need to come into play. That's key area.
What's the
So I think we need to
percentage?
develop some. Yeah.
What's the typical yield? Like, say you got plastic that's say high density
Uh,
polyethylene bales. What's the percentage yield from that
so
for
I would
fuels?
say, okay, just give me a second. I do have the numbers in front of me. Just wait that. What is it? Uh,
Let's say 50%. I'm googling it 50 to 80% by weight. So if we talk about 1,000 pounds, that's 100 gallons. Now 100 gallons is worth more to me than $50. So I can tell you right now the numbers are good.
So basically, the first part, right? You are basically getting a powder oil. You're looking at about 60 to 85% in terms of yield. And of that 60 to 85%, I would say at maximum, you get about 80% in terms of gasoline from that oil. Of which is good enough, to be honest with you, when you talk about the numbers.
Yeah, the thing that you're going to run into, and the thing that everybody runs into, is that in order to that's assuming that you're starting with a ton, or 1,000 pounds of material where you are, right? But that material needs to arrive in the place that you're going to process it, and unfortunately, transporting plastic is like transporting air, so highly inefficient to move that stuff around. And so that's kind of where all the economics is gonna make or break the process, right? As long as it can get to a place efficiently, that's great. Getting it there,
we're talking about within an hour. So recycling centers within. I looked into this just barely before, but I was, I believe I can get $50 per ton bales within an hour away. So we put. What is that? 30 of them on our trailer, and we've got 30 bales like that in an hour's worth of gas.
Yeah,
that's
good.
That's 20 gallons of gas that we paid for, or diesel that we paid for it, plus the bale costs.
Yeah, if your distribution or sourcing system is efficient, I think it's absolutely doable. So. That's going to be fun. That's going to be a lot of fun. Okay, so I think that's what we're gonna work on initially. Let's just see. Let's look at the feasibility. It seems like it's going to work, but Liberty and I will then discuss also the feasibility of producing something viable in an open source manner. Right. I know you have a big workshop. You have all the tools necessary, I think, in order to produce what you need and the materials and whatnot. It's just going to be the first step of pyrolyzing plastic. Is it even, is it going to be, something that we can construct relatively simply, something along those lines? It should be.
Marcin, do you want to buy the system, or do you want to fabricate it on your own?
Probably fabricated. We're too good at that to raise the costs by having somebody else fabricate it for us. So we're getting back into the fabrication aspect, like the CNC torch table. We're going to have that back up and running this year so we can build our own skid steers. So you can assume welding and CNC torching and other iron worker and other things.
You have a full metal shop.
I mean, if I talk to Technotherm, because they also have a full fabrication workshop, I can ask him for two options where he can allow you to fabricate, but based on their license. I wonder if that's possible. I would have to ask him that.
Find out what the license conditions are, because maybe...
but then the other option, are you open to buying the whole system?
Yeah, it depends on what the price is and what the performance is and scale and price. Yeah.
Okay.
See how much.
I will ask those two options.
What's the turnkey system like that, and what's the open source cost of it? But I mean, the general trend is if you open source something, especially that's got complexity, you're talking about 10x cheaper on an open source for you're talking about X cost. You can get that X divided by 10 for the materials. So if you fabricate it yourself, it's like X over 5 for the final product. So let's see what the economics are here.
The guy is also a British South African. So he's originally from Britain, but now he's South African. So the British, when it comes to such things, they are serious about the funding aspect. It's very important. Just I don't want to insult you. I just want to find out, you do have the funds ready, right?
How much are we talking about?
Yes. I don't.
Yeah, I don't think that's gonna that's gonna apply. We're talking in the millions at least, right?
No,
Liberty.
we can't do millions for a first
No,
first thing.
not for a small system. Getting it about 250,000
Oh,
or
really?
above.
For a small scale
Two
bench
hundred
for a
fifty
bench
thousand.
scale?
Yeah,
Oh,
250,000 US dollars.
250K,
Round
and
about
what's
it.
the production per
Yeah.
year? What's the
Yeah,
labor,
that's a bench
OpEx,
scale,
and
right?
I'll have to have those numbers, but I'm just saying from a funding point of view, about 250,000. I'm just approximating for now, to be honest with you, based on my past experience with them.
yeah,
So I would say
what
maybe
is a
two hundred
system like
fifty
that?
thousand. So the one that was 250 was a biogas system. So they were pyrolyzing a normal pine into bio oil and syngas. And then there was also an FT system to convert the syngas into diesel. The whole system cost about 300,000 or so US dollars in total.
How much?
But it was a pilot scale, 300,000 US dollars, but it was a pilot scale.
A 30,000
Pilot scale.
pilot that did what? So this was what was the starting feedstock?
Biomass,
Wood.
wood
Wood
biomass.
biomass.
Yeah, it was for a different client though. It was some
Did that include
corporation.
did that include addressing the wood vinegar issues and all that, or you just
So in this case, there was no issue of wood vinegar because they were paralyzing at high temperature.
yeah?
So when you paralyze at high temperature, you get a high yield of syngas. So then that syngas is easy to turn into diesel because you have an FT, a Fischer Tropsch. So the Fischer Tropsch then converts the syngas into wax, then
Nice.
into diesel.
So you tell me, so
Yeah,
30K for a pilot Fischer Tropsch
yeah,
process.
Fischer Tropsch.
Oh
Yeah.
man, give it to me. What's the yield on that system? On that pilot?
To be honest, I don't want to divulge because I don't have the NDA for that, so I don't
We've
want to
been
be in
talking
trouble.
about Fischer Tropsch process for a couple of decades here, and yeah, we want to do that.
South Africa, so Sasol does that. So one of the guys was working for Sasol, so he's now working for Techno them.
Yeah.
So they have a modular system, FT system, that can do something at small scale.
Man, yeah. So that's the other route. We're not talking about wood, but we're gonna start getting serious about wood. We're gonna invest in sawmills and things like that so we can produce lumber for our
Awesome.
homes. So
So
we're gonna
if you
get way into this.
if you want to produce good quality fuel from wood, right, never use the bio oil route. That's redundant because you're gonna get acids, vinegar, and tars. So what you do, you paralyze your wood at about 900 degrees Celsius. Then you get a high yield of syngas. You clean that syngas, pass it through an FT system, get a high yield of wax, then you fractionate it in a distillation column. Then you get your heavy oil, your diesel, your gas oil, your gasoline, and LPG. Simple as that.
The vinegar disappeared because it's already the high temperature pyrolysis already took care of that initially.
Yeah.
Okay.
Yeah.
Okay. So
Yeah.
here's what's a good one. Here's what I've conceptualized. So pellet stoves. So think about high temperature pyrolysis with pellets, meaning a flow controllable. So pellets as a flowable fuel. So you got wood pellets from a simple pelletizer. You do high temperature pyrolysis on that in a continuous system. So you're producing charcoal pellets out of that, and then you can also get your other volatiles out of that. But a system which is based on pellets, which means the size of that and modularity can be much, much higher because of the flowable fuel, the pellets. That has anyone talked about or discussed doing that? Because here I'm looking at, like, when we talk about, so we have a pellet stove here, and it's like, man, imagine we got house heat, but the product is actually charcoal, possibly even the fuel is in a small appliance size device that goes through that process, and the backside of that wall that has that pellet stove. I mean, I could see this as if you get serious about actually refining a highly refined appliance that does that. You can be talking about pellets for household heat, and then you're actually producing fuel and charcoal as byproducts. That's like, I could see this going even down to the home scale. Once you do open source, meaning that you actually make the design efficient and non-proprietary. So this takes more than a single company can do, I think. This is beyond what the industrial system can do right now without open source.
I mean, for it to be homemade, right? I would say the health and safety aspects needs to come into play. What I'm saying,
Sorry,
so
what aspects? I missed.
health and safety, health and safety.
Health and safety, yeah.
Health and safety aspects,
Yeah,
of course.
because remember when you design any system, if it's gonna result in someone dying, obviously there's gonna be some repercussion. So it's similar to a biogas system. A large biogas system produces a lot of H2S. So if there's any leakage, people die. And also biogas is very flammable. So if there's any leakage, there's gonna be fire. So when me and Keith build ours, we made it IBC tank, mainly because when it's at about 1,000 liters, the amount of H2S that is produced is very minimal. And even if someone is exposed to it, they won't die. That's one. So basically, we simplified a large system into a small system, but then we minimized a lot of things. So the production rate is lower compared to a commercial scale system, mainly because we were trying to compromise on many areas. Like for example, the amount of H2S produced, the flammability, and all that.
Yeah.
So if you want this to be domestic, you have to compromise many areas to meet the health and safety aspect.
Yeah.
Oh
yeah. Well, yeah. I mean, yeah, that would have to be. That's what I'm saying. This is beyond the current industrial system. This is an impossible problem.
Yeah.
I believe it's possible with open source collaboration.
Yeah, that is true.
So next step, let's go into let's go back to the bales, but also let's explore the two tracks. One is the Fischer Tropsch process for biomass, and the second one is the ton bales that we assume we can source at $50 a bale from within an hour away. Let's go through the numbers on that.
Yeah.
Do you mind elaborating when you say the ton bales? Because I think I'm a bit lost on that one.
Sorry.
Talking about the bales of bales of plastic.
Recycling centers, from what I've observed, you can source bales. They're bound bales, and it's the big cube about a meter on a side, and it weighs about 2,000 pounds or about 1,000 kilograms, about a ton. So so you've got ready bales at recycling centers that you can source from the trash stream.
Okay.
Yeah,
that's absolutely true. United States. In this Venezuela invading United States.
Oh man, that topic is
we don't have 3 hours here, but yeah, Liberty and I have been talking about that all day. No, that's a really good plan. So obviously Kansas City is going to have a bunch of recycling centers, and they're going to have your bales already, set and ready to go. You just have to outbid the other places that currently accept them. But that's not going to be terrible, and you can find those prices. Yeah, that's actually a really, really smart plan. I like that.
And we're doing this for the world so that we don't have to invade those Venezuelans, because we've got energy security anywhere. Thank you.
By the way, for the price that we just did all this stuff, we could have built like 5 light crude like processing plants in the United States and had no problem with any of this stuff. It's so crazy. But anyway, so
in terms of the bales, right? What are we trying to do with the bales? Sorry, I know the first one is okay. The waste plastics to
fuel and diesel.
That's the bales of plastic are from the recycling center are going to be pyrolyzed. That's what he's talking about.
And how big are the bales?
One cubic meter, about.
In terms of tonnage.
1 ton.
Okay. 1 ton. Okay.
1 ton cubic meter, about, or maybe a little larger. I'm not sure about, but around that area, within a factor of 2.
Okay.
We're talking about forks, dumping it into big hopper, big shredder, and then going on from there.
Yeah.
So this is exciting, because then it gets into our other stuff, the universal rotors, shredders, power cubes, all that equipment for chewing up things like bales and cars for recycling purposes. So this, I mean, I think a bit about these huge shredders. For our scale, we're talking about 3-inch shaft shedders that can do, light metal. But that kind of level of shredders, where we're cutting out the blades with CNC torch tables and actually adding carbide teeth to them and stuff like that, insertable teeth. And so we're doing all that infrastructure using the Global Village construction set type of tools that it's all in there. So
that's going to be huge. Shredders are a big part of this. It's a huge part of this, actually.
Well, what I got out of this is that, once again, it's not that pyrolysis. It's like materials handling. That's the thing. The processing and materials handling is the big deal. Yeah. Like the rest of the stuff, that's kind of like secondary. And this is where also the automation and RTK GPS mobile devices that can carry this and automate this. So you got a workshop. You got your, hit a button on your computer and you got your tractor picking up a bale, throw it in there and stuff like that. So you can automate a lot of this stuff and actually make it efficient and replicable using open source appropriate automation.
And one person who can help in that area is Keith. Oh man, he has taught a lot of the circumstances facilities and he has a number of good ideas to be honest with you. Quite a number.
It's a cool thing. We were working on something else. But anyway. That's off the case. So okay, so the next step is we'll focus on those two areas, and Liberty and I can discuss what it would take to talk about like open source pyrolysis in that instance, and we'll share plans, the biodigester plans. I think it would be a great idea if we could sketch that up in FreeCAD because I'd like that for me personally.
Well, yeah, we already have the biodigester part library on the wiki already, so you can build. I got the IBC totes and fittings in there, so you can work with that too. It's an as-built system for what we have here in the house right here. We have a biodigester here. We're not collecting gas, but yeah, that's online.
Okay. Yeah, we'll check that out. Awesome. You guys have anything else?
No, I think that's it. So let's see. When can you guys turn around with some quotes or designs? Like first, we got to find out what the other company would do for Fischer drop process.
Let's have Liberty. Let's have Liberty get in touch and let them get back to us.
Is it daylight savings? Sorry, because in South Africa we don't have that in Africa. So is it 8 hours now? Is it 8 hours difference?
It's about 8 hours. I have it right here.
Oh, okay. Daylight.
So
what?
He's Liberty. It's almost midnight over there now.
Yeah, almost. Yeah, it's just past 11.
Yeah.
So tomorrow morning I'm gonna give him a call. Hopefully they have time. So maybe by the same time tomorrow, we can have a chat, and then I'll tell you what he says.
Yep.
Yeah. Awesome. So if you want to start documenting on the wiki, I already put up some docs. Let me send it to you here, but what's going on?
If you can send me the notes, that'll be helpful to allow me to discuss in details with him, if you can.
Yeah, well, and I'll share that. I'll share those notes with everybody and the video recording.
Yeah, very nice.
Oh, great. Excellent.
Good. All right. Let's we'll regroup and thanks for the discussion, guys.
Yeah.
It's been awesome.
Awesome.
It's been a lot of fun.
Thank you. So we'll talk soon.
We'll talk soon.
Hold on.
Talk to you later, guys.
Bye-bye.
Bye.